In our first example, we have an overall reaction of x plus 2y plus 2z gives me xy2z2. When a series of reactions is performed with different initial concentrations of reactants, the results are the following. Doubling the concentration of x has no effect on the overall rate. That means that this is a zero-order reactant. When I double the concentration of y, it multiplies the overall rate by 4. That's because when I double the overall rate, I'm raising it to the power of 2, I'm going to get 4. So this tells me this is a second-order reactant. Doubling the concentration of Z doubles the overall rate. So I'm doubling the concentration of Z, and I'm going to put that to the power of 1 to double the overall rate, giving me an order of 1. Write the rate law equation for the system. My equation will be R is equal to my rate law constant times y to the second order, or to the exponent of 2. Oh, sorry, this is supposed to be a 1. And z to a 1. To identify the rate determining step, this is going to be the slowest step in the reaction. So my rate law tells me that my rate determining step will have 2y plus z. Remember that your rate law equation also tells you the coefficients in your rate determining step. If I have 2y plus z, I can make y to z. And this is my rate determining step. It's my slow step. I'm going to propose a reasonable reaction mechanism using this rate determining step, and I'm going to identify any intermediates. So my first product I know will be an intermediate because it's not in my product. I need to try to make this product, and I need to try to get to 2 z's and 1 x. Right now I've only used 2y and 1 z. So I'm going to react my intermediate in my next elementary step. And I'm going to add another z so I can get my 2 z's that I need. And this will give me y2 z2. And this will be a fast step because we already had our rate determining step. In our next step, I can see that I have used up this intermediate on both sides. I now have another intermediate because this is not my final product. So I'm going to react it, y first, with what I have left over as a reactant. I haven't used my x yet. So I'm going to use my x, and I'm going to have x, y2, z2, and this will be my fast step. When I add this all up and I get rid of any intermediates, like this one, I'm left with the reaction that I wanted. 2y plus 2z plus x gives me x, y2, z2. And this was my target reaction. Remember that there are many different ways to get to a reaction, and as long as they work out to give you the proposed overall reaction, it works.